Okay, here is a quick video looking at regression and this idea of correlation versus our p-value and a hypothesis test. And so this is to point out you can actually have a pretty good correlation and reject the well, sorry, not reject, but accept, fail to reject is what I meant to say. So we can have a good R squared, so something that would give us a reasonable correlation coefficient, and but our t statistic and then our p-value down here will be greater than 0.05. Won't be much greater, but just to show. I can craft some data. So if I make this 0.002, 0.001, 0.002, 0.005, 0.006. So now, looking at that data, if I highlight that and I insert a chart, make it XY scatter, and then just finish here. So, what we see, let's see, I'm going to make this just a hair smaller. And let's see, click out here. Bring this back over here. Just so we can see it a little better. So I'm going to edit this and I'll add a trend line. So as you look at those data, I mean, there definitely seems to be a trend. So insert a trend line and I'll get an R squared for that. And say OK. And we see that the R squared is 0.76, 0.77, somewhere in there, which says that of these data, the correlation coefficient would be the square root of that. And so the square root of that, what the heck would that be? 0.8 something, 0.85 or so. I've got a spreadsheet right here, equals square root of 0.76, we'll call it 6, 0.875. So we've got a correlation coefficient of 0.875. That is great correlation. Okay, so this has great correlation. However, if we come back over here, now I need to move this down out of the way. If I come in here and I do my linear regression, my Y data, whoops. There's my Y data, my X data, 1, 1, Control Shift and Enter. So there's my R squared of 0.76, but look at my p-value, 0.051, and so we would fail to reject the null hypothesis, but remember the null hypothesis is that the slope is 0. So the hypothesis test actually would say, no dependency here, right? I mean, there probably is a dependency. Actually, I'm sure there's a dependency, but with these few data, in this case, and a slope that is so close to 0, because the slope here is around 0.001, right? There's the slope that we've been given. The slope is so small that when we check the standard error with that slope, even though when we look here we feel like, wow, that's a nice trend, going corner to corner here very nicely, that doesn't seem like it's due to chance. Well, turns out statistically it could be due to chance, at least at the 0.05 level, right? So this is just slightly bigger than 0.05. So our p-value in our test of hypothesis, where our null hypothesis is that the slope is 0 and our alternate is that the slope is not 0, is indeed different than our correlation here, where in this case our r squared, nearly 77%, which made then an even nicer there it is, even nicer correlation coefficient of 0.875. So I would say these data are correlated. However, if I'm asking, do I think I've proven a relationship between X and Y, a dependency, I would say no, I haven't. And so you see correlation and the dependency are not exactly one and the same. They tend to go hand in hand. In general, I would say if my data do have a really good correlation, probably the p-value is going to be less than 0.05, but you see it doesn't guarantee it. So I have a good correlation, but a poor p-value. Now it's not really poor. I mean, it's almost under 0.05, but it's poor enough. And it's definitely not something like 0.01 or better than that. Okay, so keep in mind that you like to use the word correlation interchangeably with dependency, and that is incorrect. They are not the same thing. They are very related, but they are not at all the same exact thing. And so be careful of that. A correlation is how well do my data fit a straight line? And they fit pretty well here. Okay, that's a correlation. Now, whether the slope is 0 or not is a different question. So we've got a good correlation, but the slope we cannot say is different from 0. So we would not talk about a dependency here. We would have to go with independent, or at least we couldn't prove dependency, right? So we haven't really proved independence, but again, it really goes with that alternate hypothesis. We were trying to prove dependence, and we couldn't do that. We failed to reject the null hypothesis, so we failed to show dependence. So we're stuck with independence. But again, technically we haven't proven independence. We've just failed to show dependence. Alrighty, so we'll call that good for that video.